Okay, we'd like to talk about why equivalent ratios are indeed equivalent ratios. So that's a fancy word, equivalent. When we talk about ratios, in this case, I could say for every 3 red, there are 4 green. So there's our ratio, 3 to 4. For every 3 red, there are 4 green. I could reverse it and say for every 4 green, there are 3 red. But since red is first, I think that was the way I started with my brain. Okay, so for every 3 red, there are 4 green. If I wanted to make an equivalent ratio, well, I could take this and I could make a whole nother set of our original ratio. So if we think of that as our original ratio, I can make a whole set. So let's see. Ooh, I don't want that. I wrote on it. So let's see if we can do that. So let's try. So I have 1, 2, 3, and I need 4. 1, 2, 3, 4. Okay, so now I have another set. Okay, so here's another set of 3 to 4. Okay, so we have that set. So what did we do? We made 2 sets. We took our original and we made 2 sets. Well, if I think of it that way, well, let's look at our red and our green. We started off with our original ratio of 3 to 4. I used 2 sets. Well, now I have, mathematically, I have 3 times 2 equals 6, 4 times 2 equals 8, but I could also look at it as, where does this come from? Well, here they are, 1, 2, 3, 4, 5, 6. There's my 6 right here. 1, 2, 3, 4, 5, 6, 7, 8. There's my 8 right there, 6 to 8. So I could say the same thing. For every 3 red, there are 4 blue. For every 6 red, I'm sorry, not blue, green, there are 8 green. I wrote in blue, so my brain went to blue. Ooh, there's a lot going on there. So let's erase some of this. Now, so that's how equivalent ratios happen. We call that our factor of change. How many groups of that? In this case, I did 2 groups right here. I'm going to get rid of that one, because I want to show you that as slow as that is to erase, here we go, we're getting there. So I have, back to my pen. All right, let's go to this color. So I have my one group of 3 to 4, a second group of 3 to 4. Well, let's say I did another group of 3 to 4. Let's try that. 1, 2, and if you notice, for every 3, I have 4. For every 3 red, I have 4 green. I can't just do 3 and 3. I have to keep whatever was listed in my original ratio. So again, I moved them a little differently, but we still have the same original ratio. I'm going to pick purple, my favorite. 3 to 4. Well, now I went with my original ratio, so red to green was 3 to 4. Well, now I have a third group. So if I took my original, and when we have a ratio as a fraction in lowest terms, we call that the ratio value. So or the value of the ratio. So if I did this, look at that, times 3 groups, well, let's see mathematically. Home down here, 3 times 3 groups, well, what do I end up with? 3 times 3 is 9, 4 times 3 is 12. Let's check our counting. So I'm going to switch colors again. So something we could notice that's here. Oh, look at that one. I like that one. 1, 2, 3, 4, 5, 6, 7, 8, 9. There they are. My 9. Well, I'm going to count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there's my 12. So when we talk about equivalent ratio, it's how many of that grouping make the new ratio. And the ratio is still 3 to 4. And if you look, it looks a lot like equivalent fractions. So if you can understand your factor of change, you can understand equivalent ratios. And this shows you why it works. All right. Hope this helped. And, keep working hard. Let's see if I can shut this off in a timely manner. Did it.